Good day, sir. My name is Arnita, anak perempuan Surieya, and my metric number is 2340413941. And today I would like to present about my proposal entitled Micromechanical and Corrosion Properties of Titanium Doped Chromium, Cobalt, Manganese, Iron and Nickel High Entropy Alloy Thin Film. So here is the introduction. So in introduction, we can say about the high entropy alloy, which consists of multiple elements in it, and also different between high entropy alloy and also traditional alloy is traditional alloy consists of one single major element on it, and also high entropy alloy has much more better corrosion resistance, hardness, strength and many more better properties than traditional alloy. They perform well in both high and low temperature. That's why it is called as high entropy alloy. And the main high entropy alloy that become attention is Kanto alloy, which consists of CO, Cr, Fe, Ni and Mn. And it also related to my topic, which is the Kanto alloy. This alloy has good ductility and also toughness. However, there is limited research on the thin film of the alloy, since it is hard to grow and needs a crucial optimization to grow thin film. So here is the problem statement. Even though we have various of alloys and high entropy alloys, Kanto alloy gives a good properties. However, there are certain drawbacks with the Kanto alloy with its corrosion resistant and also mechanical properties. So in this research, I will research on the doping of titanium with the Kanto alloy, since titanium has good properties such as mechanical properties, hardness, tensile and corrosion properties. So I will look more on thin film and properties of thin film of Kanto alloy when doped with titanium. So here are the objectives. I have 3 objectives for my research. First of all is examine the effect of adding various of tightening percentage, which is doping, into my Kanto alloy, and look at the microstructure for both bulk and thin film. Second is to assess the mechanical properties of this material after doping. Third is investigate the microstructure and phase changes after the exposure to the stimulated seawater, which is corrosion test. So scope for my research is to investigate the effect of varying titanium percentage to doping the Kanto alloy, and I have 2 type of samples, which is bulk and also thin film. So for bulk, first of all, I will mix with equimolar percentage of different 5 element and also titanium powders. Mix it and compare it later on sinter to get the bulk sample. Then the bulk sample will be analyzed with SEM and XRD for microstructure and phase analysis, and also will conduct hardness test. And for thin film, I will use radiography frequency sputtering, RF sputtering, to grow the thin film, and there will be testing for thin film such as nano indentation and also corrosion tests. Here are the literature reviews. So first, I have studied about the alloys, which is alloy combined of multiple elements and have good properties such as strength, corrosion resistance. This study was conducted by Lee. Next, about high entropy alloy, which was studied by George, said that HEAs are metallic material made from 5 and more elements, which is equally amount equimolar. And next, about Kanto alloy. Kanto alloy has good ductility and resistant to hydrogen embrittlement, which is studied by Chang. Next is about research from Wu, said that doping titanium into Kanto alloy can improve its mechanical and structural properties. Next, about powder methodology, which is powder methodology technique like ball milling and sintering are essential to produce the HEA, which are the main major techniques to produce the HEA samples. Next is about the thin film, where thin film has much more advantage than the normal bulk, sample since it has increased surface to volume ratio and improved stability. Next, a study from Shang showed that about the microstructure where doping can influence the microstructure and also change the grain structure of the HEA, either bulk or thin film. Next, about the micromechanical property where doping can enhance the micromechanical properties such as hardness of the thin film and also bulk sample. And finally, about the corrosion properties, a study from Key which shows that doping and also HA itself are good corrosion resistant. Now we will look on the methodology, how I will conduct my research. So first I will start by preparing the materials, where my material consists of Kanto alloy will dope with titanium with different percentages such as 0.1, 0.3 and also 0.5%. And here I will start with raw material. We will take out the powder and mix it using ball milling, planetary ball milling at speed 150 rpm for 2 hours. Then I will use hydraulic press to compact the mixed sample. Then for bulk sample, we will produce the bulk sample. So for the bulk sample, we will sinter the bulk sample using a vacuumed tube furnace at 1100 degrees Celsius. For thin film, I will use radiography frequency sputtering to sputter it. First, we will preheat the target, which is silicon substrate, and next we will use the sputtering with the rotational speed of 230 rpm. And for testing, I will use SEM and EDX for microstructure analysis, XRD to see the phase changes, and Vickers micro hardness testing to look at the hardness for the bulk, and also nano indentation to look at the hardness for thin film. And finally, we'll run corrosion tests such as open circuit polarization OCP and also EIS for both bulk and thin film. So my expected result for this research is, first of all, for the microstructure analysis, where I expect to have, when we add titanium to the Kanto alloy, it will dissolve well in solid solution and create a stronger solid solutions. And also titanium can form new phases, which it can cause changes in the lattice parameter spacing, and also it will causes distortion, which helps to prevent and enhance the hardness. And next, for the hardness, when we add the titanium, I expect that when we add the titanium, it will increase the hardness and enhance the mechanical properties by forming secondary phase on the high entropy alloy. And finally, for the corrosion resistance, I expect that adding titanium, doping with titanium, can improve the corrosion resistance by forming a passive layer to the HEA, since titanium has a high corrosion resistance naturally. Here are the references that I used to do this slide, and that's all from me. Thank you.